everybody, Chris here from Dummy Plug Conspiracy. We're doing another one of these videos because you can't get through this without talking about cabinets. I'm sure there's plenty of places out there that you can buy cabinets. I opted to make my own. A lot of people do. And it may be kind of a cruel trick of this experience that after you've gone through all the pain of learning about electronics and dealing with metal and solder and things like that, cabinets might seem like the easy part. Don't be fooled. They are not the easy part. In fact, there's plenty of people out there with way more electronics acumen than I'll ever have who might not be great with power tools, or just don't own any, or just don't know how to go buy lumber, or how those little fiddly hardware bits and pieces work. So I'm going to build a short length one that's going to go right here over. It's going to be 22.5 inches wide, which is enough for me to fit in 12 modules. You'll get familiar with those dimensions. The nice thing about 5U is that, we didn't talk about this yet actually, a module is exactly the width of a standard space rack unit's height. So 1.75 inches, just like horizontal racking. So that's kind of cool. And then they call them 5U because they are also exactly the same height as 5RU of horizontal rack units, like in a server rack or an AV rack or something like that. So everything in the 5U format is standardized against how traditional racks are. I have an angled rack on the bottom and an angled cabinet on top. You don't have to do that, but once you understand how to do a square one, it's fairly easy to figure out the dimensions to make the bottom jut out a little further, or make the top jut out a little further so that you can build an angled one. I think mine is, though it might look like it's stacked on top of each other, it's actually not. Mine is free floating, and I have these all hung on posts, essentially, bolts that I put into the studs of this wall. So if none of this stuff at the bottom was here, this would still be floating on this wall. If you're going to stack your stuff, you might want to do it deeper than I did. So on your z-axis, your actual depth from the wall to the front edge, you might want to make these deeper, because if I tried to stack this, just have it standing, freestanding, I think it'd be super top heavy. And there are strategies to deal with that. You can put draw latches on the sides or something like that to connect it all to each other. But this one on the bottom just doesn't have the depth, doesn't have that horizontal footprint where I'd be comfortable stacking everything else on top of it. I don't have mine inset such that the edge comes out past the knobs. If you're going to transport your stuff, you may want that edge to be out past the knobs so that you can just put a piece of board over it and prevent anything from hitting the actual modules. That actually isn't common. I don't see anybody doing that, which is a little weird. You'll see some guys who do. And a lot of the covers that they put over these, if they're doing a proper like a rack mount case, the cover itself is what gives you that depth. But guys that are just building cabinets for home very rarely put that depth on the front edge. It's up to you. Let's see how it goes. I'm going to build this short case. You're going to watch all the steps it takes me to get there, and we'll see how it turns out. Before you get into this, it is a good idea to do a little bit of planning. I mean, you don't have to be obsessive about it, but the minimum, which is definitely what this represents. All I'm really doing here is indicating my length, my depth, my height, but I'm doing it in such a way that I'm taking into account where the pieces of wood actually are. So this side block is 8 7/8 inches. However, I didn't even bother with the measurement all the way from the top and bottom of the actual unit, because remember, I got a 1/2 inch of wood laying there and a 1/2 inch of wood laying there. So really, it's 9 7/8 total height, but I don't even want that dimension here confusing me. I only want to see 8 7/8 because that's what I actually have to cut. First thing you got to talk about is wood. You can do kind of whatever you want. I found that 1/2 inch ply was the way to go, and I use finished grade maple. You don't have to use finished grade maple. You can stain it. I decided not to stain mine. I just use a satin urethane coat on it. Because again, at first I had my eye on this really cool purple stain, and I thought that would make my cabinets look really interesting, but as I started making my modules look crazy, I decided that the cabinet should look kind of normal since the modules are so weird. You know, maple's good. It's got a grain you can see, and we'll talk about that more in a minute. It's certainly thick enough. I wouldn't want to go any bigger than ½ inch. ½ inch is thick enough that you can get a screw into it without splitting it, as long as you drill a pilot hole first. So 2 foot by 4 foot seems to be just about perfect. I get a good yield out of each of the boards, so I don't find myself with a ton of scrap. And of course, you know, this stuff ain't cheap. You could easily pay 35 bucks for a sheet of that, which you don't want to mess up a cut. You don't want to have a lot of scrap. You don't want to be throwing that stuff away. So anyway, I got my lumber. I've got my corner braces, my screws. I've got my urethane. I've got my wood glue. You know, good wood glue is fairly important. And I've got my angle irons, and this is what we're going to, of course, screw the modules into. This is just a ½ inch by 3/4 inch aluminum angle iron. I buy these in 36-inch pieces and cut them down. I don't remember how much this costs, but they're not terribly expensive. Some people will tell you wood is the way to go for your actual module mounts. I don't like that approach quite as much, because if you screw into it a couple of times, you're not going to be able to keep using it. Eventually, it's just going to get all screwed out. I want to emphasize that I don't have just this huge wood shop here. I don't even have a table saw, which normally to cut a 4-foot section, you would want to use a table saw. That's really the right way to do it. But if you can give yourself a reliable guide and a good cutting chuck that you've measured carefully, you can get by with a circular saw, just a regular old hand saw, which is what I'm going to use. All right, so I've set up a workbench here that's pretty rudimentary, but you get the point. And I was talking before about knowing where your cut width is against your guide. So this particular guide distance to the actual blade is exactly 1 7/16 inches. In fact, I wrote it right on the saw so I'll never forget. The way I did this was pretty simple. I figured out where my cut line is, and then I went 1 7/16 back and clamped down this nice straight board, so I know I've got a good reliable surface to hug up against when I put this guide on there. And if I run this thing nice and straight, I should have a perfect cut. I also put a blanket down on the driveway so that when this scrap piece falls, it's not going to get the corner dinged off of it or anything, and I can still, you know, use it and it won't get all chopped up. Because if it just hit the concrete, you know, I could mess up that whole piece of lumber, which would be a shame, because obviously I got other stuff to build here too. So make sure you're clamped down to your surface, not just down to the wood you're going to cut. You got to make sure the whole thing can't move. I just use these hand clamps. There's a million different kinds. But get it on there tight, because you never know when you're going to hit a bump or have to reposition yourself mid-cut. There's nothing fancy about this saw except that I put a nice finish blade on it. So remember, one of the things that happens when you cut wood is you lose a certain amount of material just from what turns into sawdust as the blade goes through it. So when you're doing your measurements, you want to allow a little bit for that, and hopefully you don't lose too much. But again, now we've got our bottom piece, our top piece. We've got our 2 end caps. They're going to sit like that and turn this thing into a box. And I also cut 2 back pieces that are going to act as the mounting points. I'm going to cut these with a keyhole mount that I'll show you in a little bit, so that I can hook this on to bolts that I drill into the wall. So the next thing we got to do is take some medium grit sandpaper and get all the roughness off of this. Like I said, I don't have the fanciest tools in the world, so I'm going to have to get rid of some of the little dips and fuzziness that happens on here, because once you get to the next step, especially when you start trying to urethane these or stain them, that stuff's all got to be gone. It's also nice to not have it get stuck in your wood glue, because that just makes everything get really goopy. So I'm going to clean these up now with some medium grit. I think this is, I don't know, I think it's 400 or something, but it doesn't really matter. This is just a quick run on the edges. You also don't want to overdo this, because you don't want to round those off. You want to keep them pretty crisp, nice 90, but you still got to give them a shot on each edge. Like I said, we've got all our bits and pieces now, and we're going to start assembling this. There's really no great way to do this. I'm sure somebody has a better method than I do, but what I have found works so that you can get your corners nice and tight and have the stuff match up as good as possible
is to use these little corner braces. Not really so much because you need the support, but it just gives you a great guideline, like a template to work with. So what I do is I get these as close as I can, and then I set that in there and kind of mark the center points in each of those holes. All right, now that I've done that, I'm going to take a Phillips head, and now I'm going to go ahead and position it and drive it. But I'm not going to drive it all the way. I'm going to get it in there about a ½ inch so that this thing still has a little bit of play. And then I'm going to wait a second. I didn't drill a pilot hole because I want this to really bite and just kind of hang out. So now I'm going to take this, and same thing, now that I've got that positioned, I can go and screw it in about halfway and just get it to a point where that's not going to go anywhere. It's just kind of hanging out there, and I've got it roughly positioned, but now I've got play to square it up before I actually go into the top and bottom with these longer screws. But now I can move these so that when it comes time to put a bead of wood glue in there, I have a way to do that because I can move this out of the way. It's kind of nice, right? I've learned that, you know, wood glue is a huge part of the process because the glue is stronger than the wood. So once you get that in there, and again, you can clean it up after, it doesn't have to be perfect, but then you're going to screw these down. So there, by the time you're done, you should have this pretty well where you want it. Of course, this is not the last step. You're still going to go in and drill in from the bottom and put screws in there. So as long as this is pretty close, you're just giving yourself an advantage. So this glue has started to cure a little bit, which is going to help you out on the next step. Because you're going to take a drill, make sure you pick a bit that is smaller than the diameter of your screw because you're going to make these pilot holes now. I don't really measure these, I just make sure they're in the middle of that ½ inch allowance that I have for the piece I'm screwing into. I'm going to put one about there and one about there, just so they're in a bit, and then I'm just going to kind of carefully drill a pilot hole. Not even that carefully, really. I mean, it's just got to make sure you're not too close to the edge here because you don't want your wood to splinter or split. And try to keep those, keep them as straight as you can. You want the screws going in straight. I'm using these number 6 1-inch lag screws that give me a little bit of unthreaded there, and that's the part that's going to sink through the top because we don't want that to split. Obviously thread's got to go through it, but you don't need thread there once it's sunk in. I also like to take a tap of wood glue on both of these just to make sure you're giving yourself every advantage, because, you know, I think I said it before, the glue is stronger than the wood, so it's always worth giving yourself a little bit more strength. And then I'm just going to drive these in. You want to countersink these very slightly, just so they're not sticking up above the surface of the wood. But if you try and sink them too much, they're going to create kind of a divot, especially with maple, because it's a little soft. So just watch what you're doing, get it just countersunk, but not like so far that it's creating a big dip in the wood. The beauty of wood glue is that it sands just like wood, so don't worry about those. Come back to them later and just hit them off with some sandpaper and it'll just go away. You're going to have to do that anyway before you stain or urethane. So I'm going to go ahead and do the other side, and then I'm going to flip the whole thing over and do the whole process again with the braces and everything. And when I'm done, I'll have a box. Okay, there we have it. This is a cabinet, essentially a box with no back. We are going to add a back. Some people like to do the whole back covered. I don't do that because of the way that I mount things. So I'm going to fix these two pieces in here, but first I have to put a keyhole mount in them, and I'm going to mount it on this bolt, the end of which is going to be sticking out of the stud. So the idea is to be able to hang it on there and then have it hook down and have gravity kind of hang on to the thing. So what I got to do is put a bigger hole on the bottom and a smaller hole on the top. That way I can get it over the head of this bolt, but when it hooks down onto the shank, it's gonna sit just perfectly. So I'm gonna measure a 1/2 inch down on both of these, which is right there. Let's take my 3/4, and I'm going to line that up so that it's just under the 5/16 that I just did. Well, that's obviously not done yet, but we're in the ballpark. Now we're going to take the jigsaw out between the two holes so we got a nice straight channel. So now, maybe this will make sense, where if you imagine that this bolt is in the wall and this is gonna hook onto it and then sit on the shank, that's what's gonna make the whole synth cabinet sit on the wall and not go anywhere, because gravity is going to hold it right onto that shank. And the beauty of this is you can actually go in and tighten this up a little bit more to hold this right flush against the wall and keep your cabinet from moving around, and that's going to be more than enough to keep this thing secured. Next thing we got to do is cut our rails. I'm going to cut this with my miter saw. Notice that I do have an aluminum cutting wheel on here. You can't do this with a regular, wood blade, obviously, because it'll just grab this and chuck it across the driveway. Also, when you do this, you got to make sure you put the point up. Don't try and cut into the edges, because same thing, it'll bind and try and throw the thing, and it'll kick back and you could get hurt. So I'm gonna go ahead and tighten the chuck just a little bit in case this thing decides to kick for some reason. It's also going to get a bit hot. So if you are going to hold this thing on with your hand, this is only going to be a quick cut, but if I was doing anything longer than this, or if I was doing more than one, I'd want to wear gloves. And of course, I'm wearing eye protection. Obviously, I think you're going to notice that cut is real raggedy. I'm going to have to sand that down, but the beauty of aluminum is you could just use regular sandpaper and get rid of that stuff. You can also take a pair of 10 snips or something and chop most of it off before you even start sanding. So.
Stud finders are great, but you're either depending on the digital one that's a little sketchy, or you're depending on the screws being exactly where you think they are. I like to go in with a probe nail and just be totally sure that I'm right about where the centers are on studs. They're supposed to be 16-inch on centers. That's code, but I mean, framers do whatever they want once they get in. So I'm just going to go here and nail one right in the middle. All right, so that's definitely stud. Now I'm going to go over to the edge. That is also definitely stud, I think. Let me just make sure. Nope, definitely not stud. So I know that if I'm over here or over here, I'm okay. Let me just probe another one. Definitely stud. So now I know that in truth, my safe zone is between this hole and this hole. And I'm just going to mark that, which again, seems like I'm splitting hairs. But, you talk about a 1/4 inch difference or even an 1/8 inch difference. It's the difference between that big lag bolt being in the middle of the stud or being right on the edge of it, where it's going to split the wood or potentially go in sideways and stick out or whatever. All right, let's get these lag bolts in here. I'm gonna drill them out first, hit that stud nice and straight, hopefully. Of course, I'm not gonna put these all the way in because I want to have enough sticking out that I can kind of finesse this once I get the cabinet up here. Right, this is kind of the moment of truth. I mean, this is the point where you find out that your builders didn't do a good job making the wall plumb. They didn't do a good job keeping the studs on centers. We're not going to worry about all that, because we're also going to discover that we weren't dead on perfect with our levelness or our plumbness either. So you get it as close as you can. Like anything else in life, you got to kind of accept that it's not going to be perfect the first time.
Now you're going to do one more layer of sanding just to hit some of the glue spots and some of the stuff that you're going to be able to see. Now some people are going to want these to look like classic Moog cabinets. If you want to do a classic Moog look, you'll probably get yourself a mahogany stain or something like that. I just do clear urethane on mine. But the first thing you want to do either way is give this thing a wipe with water, which might seem like a weird thing to do, especially if you're getting ready to use an oil-based stain. The thing about water, regular old water, is it lets the grain open up and kind of stay open, so that when you do put the stain or whatever on here, urethane in my case, it just takes it so much nicer. This is a trick I learned from the late great Craig Lowe, one of the greatest commercial painters who ever lived. Okay, so this is the step where some people would be applying stain. As we discussed, I'm not doing that. Instead, I'm going to put a clear satin urethane, just your basic Minwax stuff that you can get practically anywhere. One thing, by the way, when you get this stuff, you're going to be tempted to shake it up. Don't do that because it creates air bubbles, and when you spread this stuff on, you do not want air bubbles because it'll dry that way. The stuff dries fast enough that if there's a bubble, it'll literally dry as a bubble, which you don't want. We are going to sand this afterwards, but still, give yourself every advantage. Stir this stuff with a stirring stick. There will be residue at the bottom. You're going to have to stir that up, and do yourself a favor. Don't make it any harder than it has to be. I just realized I'm using a really crappy brush for this, but it's okay for a first coat at least. And just get this stuff on here, fairly thin coat, but as you do this you should see some nice grains start to pop. And yeah, of course it depends what kind of wood you're using, but I really was pleased with this the first time I did it, which was a bit of an experiment, and I decided I was going to stick with it through the rest of the project. So just make sure it's applied evenly. You don't want to have lumpy sections where you put on a lot more than you did others. And you know, do the best you can. You don't want to run over it 100 times because it will start to dry, and you don't want it, you know, pulling hairs out of your brush or anything. Coat 1 finished, and this does go on fairly rough. When you run your hand over it, I mean, geez, you can almost hear it. It's going to have a lot of little bumps and lumps in it. That's why you take some nice fine, what is this, 400? Yeah, 400 grit, extra fine sandpaper. Now we're going to give this a shot, and then we're going to put on a second coat, and then we're going to be darn near done with the finished part of this. Now we're going to do our second coat, final coat, and this time I'm using the right brush. I was using a kind of a disposable brush before. I'm going to use a decent one for the final coat. And this time you want to be even a little bit more careful. Just make sure those strokes are nice and even, coverage is nice and even, because this one you aren't going to sand. So if you do it right and you don't use too much, you won't have to. And you know, just take your time. It's going to be a little harder to see where you've done and where you haven't this time, because of course that grain has already absorbed one layer of urethane. So also remember that the second layer of urethane is going to partly dissolve the first layer of urethane, so you want to be real sensitive to that. And once you feel like you covered everything, leave it alone. Don't touch it again. Alright, so taking a look at our rails. So we've got our cabinet, which is essentially stained and finished and done. Nothing more to really do to that. And we cut our rails earlier, of course, and sanded and made them look nice. And it's time to go ahead and install them. I didn't even measure this. I just kind of eyeball it, but all of them will, you know, hopefully be the same. So, you know, once that's where you want it, I usually start with the inside, the middle screws, so that you can do that afterwards. You want to kind of give yourself the ability to rotate it back and forth. Remember, a while ago, one of the other videos, I talked about the importance of spacers, these tiny little acrylic spacers, and just perfect example, these blobs of solder, just the nature of the pins that come through the bottom here, these are too tall for me to screw right down because they're going to touch the bottom, and it's just going to make the thing inconsistent. So instead, we're going to put the screw through there, put the spacer on there, and that's now going to stand it off enough that nothing's touching down, which of course you want to avoid. Other than that, this is just another case of screwing it in. By the way, you might be tempted, there's tons of screw holes on here. You might be tempted to only do 2 here and 2 here for a total of 4, but don't do that because this thing flexes. So if you don't have at least one set in the middle, when you're pushing connectors in and out of here, it's just going to be flexing, and you don't want that. It's just inviting problems. So we'll do it the right way, and we'll start with one of the easier ones to reach, just so we can make sure we got a great starting point. I'm going to line this up kind of against the back wall, but you know, it doesn't have to be precise. Probably right there is good. And that means this is a good spot to drill in. Let's get our power inlet installed here. We haven't really talked about, you know, actually installing the modules yet. But, you know, I use a mechanical pencil with the lead extended way out so I can get all the way down and mark. But you can't do that with a regular pencil because it won't fit. You can't do it with a pen or a marker, really. So it seems like a silly thing, but it's just a good little tip. I shrink it back. Let's drill these guys out. Doesn't have to be exact, but you want it as close as possible. And again, I said before, I like metal rails because the screw bites into it really reliably. So you get a nice, solid, secure connection here. Okay, that's in there good. Certainly not going anywhere. And now, if you can see, I'm going to take my power tail from the back of this and plug it into the distributor inlet. So now power that I plug into the front is going to get distributed across all 6. Well, we did it. We've got our cabinet in the studio ready to hang it on the wall. Let's see if it fits. First of all, it should. We already did all the testing. So we're going to hang it on those smaller holes and then let it drop onto the, or hang it on the bigger holes, let it drop onto the smaller holes. And to me, that looks pretty good. So I'm happy with that. I think we did a decent job here. You might have noticed I have my voltmeter sitting in here because one thing you always want to do after you wire power distro. Let's get this thing set for volts and let's fire this up. I do have one of my power cons ready to go, so this guy's now connected, and I'll fire up just the power supply that's feeding it. All right, and we'll take our probe. And if everything works, I should see -15 on that pin, and I do. I don't know if you can see that. And I should see +15 on this pin, and I do. Good. Everything worked. I'm happy with that. And as you can see, like I promised at the top, don't underestimate how important cabinets are, how long they might take to build, especially if you've never done this before. And I mean, I don't have any training, I've only got experience, but you know, it's not a hassle exactly, because you got to remember, you're going to get to build it exactly the way you want it, and that's what makes all this worthwhile.